Imagine asking a computer to write a Shakespearean sonnet about a toaster, and within seconds it produces a perfect rhyming poem. How does a machine sitting in a server farm somewhere understand your request and reply in flawless, natural sentences? This process uses the same logic as your phone's keyboard. Type "thank" and it immediately suggests you. It isn't thinking about gratitude. It's simply noticed that across millions of messages, you is the most frequent word to follow. The most advanced AI doesn't experience language the way humans do. It is essentially playing a massive, high-speed game of guess the next word. Teaching computers to communicate with us has always been a struggle because computers speak in the rigid math of ones and zeros, while human conversation is messy and full of exceptions. Early engineers spent decades trying to manually program thousands of strict grammar rules into these massive, room-sized mainframes, hoping the machines would eventually learn English. But we don't always follow the rules. We use slang, sarcasm, and weird phrases like break a leg that make no literal sense. When a rigid program hits these expressions, the entire logic falls apart. To bridge the gap, researchers realized they had to stop acting like grammarians. Instead of giving the computer a rule book, they needed to let the computer find its own mathematical patterns in our speech. This led to the creation of large language models. If your phone's keyboard learned from a few thousand texts, these models learned by scanning almost the entire public internet. To handle that much information, the computer chops words into smaller puzzle pieces. For example, hamburger gets split into two pieces, ham and burger. Reading billions of pages, it maps which pieces sit together, building a massive, interlocking web of connections. This web contains hundreds of billions of individual settings that define the relationship between every piece of data. What looks like intelligence is actually the model using this giant map to determine the probability of which piece of a word should come next. Even with a great map, older programs had a weakness. They read text one word at a time, often forgetting the beginning of a long sentence by the time they reached the end. In 2017, a new way of organizing these models, called a transformer, solved this memory problem. It uses a feature called attention. Imagine a crowded room where you tune out the background chatter to focus entirely on the one person speaking. The transformer does the same thing with text. It looks at a whole paragraph at once and uses glowing threads of data to connect words that relate to each other, even if they are far apart on the page. This ability to weigh which words are most relevant to the current conversation is what gives the AI its sense of context and memory. Once a model can see context, it can perform tasks that go far beyond simple word prediction. To translate a sentence, the model doesn't need a dictionary. It simply recognizes that the pattern of data for a thought in English mathematically aligns with a similar pattern in Spanish. When summarizing, the attention mechanism identifies the most important parts of a long document. It keeps the heavy core nodes of information and discards the lighter, less relevant filler. In every case, the computer is using the same process. It is looking at the context you provided and predicting the next most likely piece of text. But because the system is only predicting the next word based on a map, it doesn't actually know if those words are true. This can lead to factual errors. The model might confidently follow a path of words that sounds perfectly natural, but actually leads to a complete lie. The machine isn't trying to deceive you. It has no concept of what is real and what isn't. It is just making a very confident statistical guess. This also means the model repeats our own flaws. Because it learned by reading billions of our conversations, it absorbed our patterns of bias. If its training data frequently links certain groups of people to specific roles, the model's next word guesses will simply continue that same imbalance. These tools are incredible calculators, capable of reflecting the vast patterns of human language back to us. But they are not minds, just very, very good at guessing what we might say next.